Alright, let's have two quick more examples of using these trigonometric functions. This time we're going to be looking at, well, it's going to be useful to know the inverse functions, right? So again, we know that the definition of sine is set up in this way, such that it's the ratio of the sides of the right angle triangle. This time the question is, what is this angle theta? Now I know I can still write down the relation. By definition, sine of theta is opposite over hypotenuse. Okay, and now my question is, well, what is theta? Well, that's easy. Now that I know what the inverse function is and how to like deal with that and how to play around with that, I can just take the sine over. So I get this. And all we need to do is find out what arcsin of 3/5 is. And from memory, what is this? I think it's about 38 degrees, maybe? Yeah, I'm not exactly sure. You could check that on a calculator. But yeah, and the reason why this works is because arcsin is 1 to 1, at least in the range 0 to 90, so we don't have to worry about any of that when we're dealing with right angle triangles. Okay, but yeah, it's a pretty simple process. Just put the arcsin in your calculator, you can get out the angle, right? So let's have another example. So we're gonna have theta here this time. Let's say the sides are square root of 3 and 2. You'll probably remember this triangle from a previous video. So we have what relation is this? We have the opposite. Oh, sorry. Actually, I want to make that side over here. Right, so what relation is this? We have the adjacent and the hypotenuse. So this is cosine. So I'm going to write down cos of theta. That's going to be root 3 over 2. Hence, theta must be arccos. Right, just applying the inverse function. Root 3 over 2. Hence, arccos of root 3 over 2. I know that if I work out that value, that will be 30 degrees. So theta is 30 degrees, right? And let's just do one with tan for completeness. Let's mark the angle on here. So it's theta. And we're gonna have, no, let's say 3 and 4. So to set up the tan relation, it's opposite adjacent. So we have tan theta is opposite over adjacent. Yeah. So that means that theta is arctan of 3/4. And again, if you work out that, it'll be same as the first answer, right? About 38. What's the reason for that? Well, let's compare this little triangle here. Using Pythagoras Theorem, we can work out that this side must be 5, because 3 squared plus 4 squared is 5 squared. And you'll recognize this triangle is a 3, 4, 5 triangle, and we wanted to calculate the angle which was opposite of 3. Now going back up here, this is just the same triangle, right? Because this must be 4 by Pythagoras Theorem. We were just given the two sides in a different way, and we had to relate the correct relation given what we had. And now you'll see there's actually a link between sine and cosine and Pythagoras Theorem, which we're going to talk about in the next video.